Okay, AP Calculus AB, Unit 5, Day 10, office hours. This is the pretest. So if you haven't had a chance, you could check your answers real quick. Pause the video if you need to. Okay, pause the video, and then I'm going to scoot up a little bit so you can see the ones at the bottom. So the ones at the bottom are there. So if you need to see it longer, pause the video. All right, here we go. This is probably a little bit longer than the actual test. But, you're going to need to be ready for this to feel like you can get it done in the amount of time given to you. The way to get to be ready is to practice it. So, let's see. So here we're just doing derivatives. I personally would change this to minus 2x to negative 1. So you could do f prime of x equals 12x squared plus 2x to the negative 2. Final answer, I want positive exponents. If you leave negative, taking off points. Now, you could have done quotient rule for that second part if you want. I guess I could show that. You get 12x squared minus low d high minus high d low all over low squared. That goes away. 12x squared plus 2 over x squared, same answer. So, up to you. Next one, I think I'm doing quotient rule on this one. So f prime of x equals low d high minus high d low all over low squared. Now let's clean it up. 4x squared minus 12. Now I'm going to distribute negative and 2x at the same time. So it's going to be minus 8x squared minus 4x. Leave the bottom factor. The top we're blowing up just so we can, potentially refactor at the end to simplify this. So it's going to be negative 4x squared minus 4x minus 12. We could try and see if we can factor it. Okay, we take a negative 4 out, x squared plus x minus 3. I don't think we're going to be able to get anywhere. Yeah, no. So you just leave like this or like this. Either one. Okay, next one. We could do, quotient rule on this one too. F prime of x equals low d high is 0 minus high d low all over low squared. So I use a lot of parentheses when I do quotient rule. I feel like it's easy to kind of mess up. That goes away. So you can get negative I don't know, either negative 12x minus 24 over x squared plus 4x squared. We could see if we try and factor it. That would be negative 12, x plus 2. This would be x squared, and then x plus 4 squared. So I took an x out, but I had to get squared. This is the best you can do. So it didn't really lead to any more simplification. So either of those are fine. Okay, number 4. So, this looks gross. My best advice is, I think, to just multiply this all out. I mean, we could do product rule within a product rule, and it's going to be crazy. So I think I'm going to distribute this, and I think that's going to be worth it. So it's going to be 2x minus 4 plus 5 minus 10 over x, right? So then that's 2x plus 1 minus 10 over x. And then we could distribute that to the next part. So that gets distributed, that gets distributed. So we're going to get, let's see, 2x to the negative 1 plus 6x plus 1x to the negative 2 plus 3 minus 10x to the negative 3 minus 30x to the negative 1. So I'm changing everything in negative exponents because that's going to be easy to take derivatives with. If there are any, we could rewrite it if we want. Highest exponent to lowest exponent. There are 2x to the negative 1, so it's going to be negative 28x to the negative 1 plus x to the negative 2 minus 10x to the negative 3. So I haven't done any calculus yet. I've just tried to multiply this out. Now the derivative is going to be easy at this point. It's going to be 6 plus 28x to the negative 2 minus 2x to the negative 3 plus 30x to the negative 4. I'm going to rewrite it with positive exponents for your final answer, which I need. There you go. Or you could try the crazy way of doing it. All kinds of product rules. I don't think that's going to be better. Here I'm going to do product rule. Sine times root of cosine is negative sine plus cosine times root of sine is cosine. So we get negative sine squared plus cosine squared. That is not a trig identity. I mean, there are ways that you could try and manipulate this, but it's totally unnecessary. I mean, if you're just thinking about it, cosine is 1 minus sine squared. So I guess you could write this as 1 minus 2 sine squared. But is that, whatever, I don't care. I'm not looking for that. Or you could have changed it to all cosines, got rid of the sine squareds, but it doesn't really cancel anything out. Okay, number 6, I'm going to do quotient rule. Low d high minus high d low all over, low squared, lots of parentheses. So that's going to be 3x squared cosine x minus 6x sine x over 9x to the fourth. Now we can reduce this a little bit, and I do want you to. Like, we could take 3 out of everything on the top and 3 out of everything in the bottom. Take a x out of everything in the top and x out of everything in the bottom. So x cosine x minus 2 sine x over 3x cubed is the best answer. Alternatively, like, you don't have to do quotient rule always in these situations. I mean, you could do, product rule by changing this to 3x to the negative 2 sine x. You could do product rule with that. I don't know if it's that much easier, or I think it's probably about the same. I mean, and then you rewrite it with positive exponents. You get 2 separate fractions, which is okay. That's fine. Anyways, just give me different ideas. Here, definitely do product rule. and then clean it up. I definitely want stuff in front of trig, not after it, for your final answers. Okay, seems good. Now this one, we could just do product rule the way it is. You could consider changing it to 1 over sine, cosine over sine. But then you're going to be doing quotient rule, which is fine if you want to. Or you could change it to product rule. I don't know if any of those are that much better. So I'm just I'll do it a couple ways. I'm gonna do it the first way. So f prime of x equals cosecant times derivative cotangent. Derivative tangent is secant squared, so this is negative cosecant squared plus cotangent x. Derivative cosecant, derivative secant, secant tan. So cosecant is negative cosecant cotangent. Remember the derivatives of the any co-derivative, any trig function are going to have a negative. So then that's going to be negative cosecant cubed x minus cosecant x cotangent squared x. I mean, that's fine. Perfect. That's that's good. Or, you could do a quotient with that. And your answer is going to be different because it's going to have all kinds of sines and cosines. It should be equivalent. I mean, we could change this into sines and cosines, probably be the same kind of answer. So low d high minus high d low. Now when we do d low, that's going to be 2 sine x because that's power rule first, and then a chain rule all over low squared. So that'd be negative sine cubed x minus 2 sine x cosine squared x over sine to the fourth. And then we could reduce at least a sine out of everything. So it'd be negative sine squared minus 2 cosine squared over sine cubed. I'd want you to reduce it. So, I guess that answer, is fine. So, some of these problems you can do different ways. There's different correct answers. Second derivative. So the first derivative, secant, is secant tan. So the second derivative is going to involve product rule. So it's going to be secant times derivative tangent is secant squared plus tangent times derivative secant is secant tan. So then we could write secant cubed plus secant tangent squared. Seems like the best idea to me. Okay. Number 10, a third derivative. True or false? Is the first function equal to the third derivative? Well, let's find it. Y prime equals cosine x. Y double prime equals negative sine x. Y triple prime equals negative cosine x. So does f of x equal the third derivative of x? Well, first function was sine x. Third derivative is negative cosine x. So no. False. True, false. I need work to back it up. Good work. Clear work. Okay. Find the equation of a tangent line. All right, well, we need point. So let's plug that into the equation. We got the x, we need the y. So it's going to be root 2 over 2. So our point's going to be pi over 4 root 2 over 2. We need the slope, so we got to find the derivative, which is cosine x, and then evaluate the derivative at pi over 4. Which is root 2 over 2. So that's your slope. So the equation of the line is going to be y minus root 2 over 2 equals root 2 over 2 x minus pi over 4. Please just leave it like that. Done. Done. If you really wanted to change slope intercept form, this one's kind of gross. I'll do it for you. But you don't have time, and you don't really want to make mistakes and lose points for stuff you've ever done correct. Okay, number 12, find k if this is tangent to this. So this is the tangent line to this function. Well, there's two things that a tangent line and its curve share a point and share a slope, right? So the point they're sharing is they'd have the same y value, the same x value, so then we could use like a system of equations substitution and plug this in, okay? But we have another unknown, so then we could do slope. So this is the point they share. If we did slope, we're going to get y prime equals 2x, and the other y prime equals 12. And since they share a slope, then their slope should be equal. And then, oh, look, we can find the x value. Now, they didn't ask us to find x, but you need x to find k. So now we can plug this in up here. So, tangent line and a curve share a point and a slope. (13) Find all the points from negative 2 pi to 2 pi where f of x has a horizontal tangent. Negative 2 pi to 2 pi. A lot of times you do 0 to 2 pi, but horizontal tangent, so our slope is 0. So we're going to take the derivative and set it equal to 0. And then solve. So sine equals 0 at 0 plus pi k. So x equals 0, pi, 2 pi, negative 2 pi. The ends are on the interval, right? Okay. Next one, f prime. Derivative tangent is secant squared, so negative cosecant squared equals 0. Then I like to change this to negative 1 over sine squared, right? And then we could try and like solve this, flip both sides. Is sine ever undefined? I mean, some of these graphs are undefined. Is sine ever undefined? No, it's not possible. Sine squared itself is always between negative 1 and 1. So, can't happen. So we say none. There are no horizontal tangents to that graph. Okay. 14, find A and B such that the tangent line at 1, 5 has a slope of 1, 8. Okay. So we know that this xy pair has to be able to be plugged into the equation for it to be true. So we start with that to get one relationship. We have two unknowns, so we need two relationships. So that's one relationship. It's the point. Then the slope, y prime equals 2ax plus b. And we know that y prime at 1 is supposed to equal 8. So 2ab plus b equals 8. That's your other relationship. Now you could do like, this is system of equations. So, it's up to you how you want to do it. We could do elimination, subtract a, subtract b, subtract 5, subtract that equation from this one. We get a equals 3. And then plug that into either of these other equations to get b. So you get 5 equals 3 plus b, b equals 2. So I use elimination. You could use substitution. It's, whatever your favorite Algebra 1 solving systems of equations technique is. Now this one says, show that this satisfies this equation. Well, there's y double prime, y prime, y. So we should probably go ahead and find y prime, y double prime, plug them all in here and see if it's true. It satisfies it. So I probably would want to think of this as x to negative 1 because that makes the derivatives really easy. Otherwise, you're doing quotient rule. Negative 1, x to negative 2, y double prime equals positive 2, x to negative 3. Now we could change them back to fractions. The negative exponents are just really helpful for derivatives. So if we're going to plug all these things in, so we have x to the 4th times 2 over x cubed plus x cubed times negative 1 over x squared equals x squared times 1 over x. Simplify it. 2x, right? Minus x equals x. X equals x. Yep. Show it all the way then. Use the quotient rule and the fact that secant equals 1 over cosine to prove that the derivative secant is secant tan. So we did some of these in the notes. So what we could do is say, okay, well, the derivative secant is going to be the derivative 1 over cosine. So we could do like a quotient rule, low d high minus high d low all over low squared. That goes away. So we get sine over cosine squared. But we're trying to make it look like this. So we can split it up, do 1 over cosine first, and then sine over cosine next. And so then 1 over cosine is secant, and sine over cosine is tangent. There you go. All right. Now we got a bunch more derivatives involving the chain rule and pretty much all the other rules at the same time, right? Product, quotient, power, trig. So just got to make sure you work carefully on these. You got to do the outer rule first, leave the inside the same. Don't forget to decrease the exponent by 1, and don't forget to, sometimes people forget it, and then don't forget to do the chain rule. Now we put parentheses around this if there's multiple terms. You could put parentheses around it whenever you want, but you really need it if there's multiple terms. This time there was multiple terms with the derivative plus 3, 0, so I just didn't bother. Write your final answer nicely. All right, next one. The outer rule is the sine, so we take the derivative of sine as cosine, leave the inside the same, times derivative of what's inside. Now, I definitely need parentheses here. It's going to be 2x plus 5. If I don't put these parentheses, it doesn't look right, even if you somehow do pull up the final answer. Same as mine. Now, we usually put stuff in front of trig. That's not in front of trig. That's not inside the trig. This would be your best final answer. Okay? All right, next one, I'm going to write it as a 1/2 power. So that's what it is. Radicals are rational exponents, so they're power rules. leave the inside the same. Now, this is sine, the same thing as sine 2x cubed. So be careful, the cubed is the next rule. And then the sine 2x stays the same, and you lower the power. And then the derivative of the sine is cosine, and the inside of it stays the same. And then the derivative of 2x is 2. Oh my gosh, how many layers of chain rule do we have right there? Now, final answer, I don't want negative exponents. Okay, we changed the 1/2 back to the square root. So the negative is going to end up in the bottom. Now the 2's cancel. So we get 3 sine squared over the square root of sine cubed 2x. 3 sine squared cosine 2x. I forgot the cosine. So, I mean, I think that's fine, you know. I mean, I think that's fine. We could take this is sine cubed, so you could take the square root of sine squared out, and it'd be sine, and there would still be a sine left over inside. So we could simplify this a little bit. I mean, we could rationalize the denominator if you did that. I mean, so that's fine. I mean, the original one's fine. So we could keep going. I mean, so, anyways, at 20, you know, you could do quotient rule, but you could also do this. I think it might be worth it. You know, change to a. I mean, I'll do it both ways. So, if you did quotient rule, you'd say low d high minus high d low. Now d low is going to be 2x plus sine x to the first times derivative of what's inside. You definitely need parentheses 1 plus cosine x all over low squared. But there's already a squared. So that goes away. So we get this is kind of an ugly answer. Well, there's an x plus sine x in the top and bottom, so I'd probably keep that factored. So negative 2, 1 plus cosine x, x plus sine x, and then there's a x plus sine x to the fourth. So we could reduce that a little bit. So, I mean, that could be your answer. That's one way you could find it. The other way is to do what I was showing you here and just get rid of the whole quotient rule idea. Give a negative exponent. It's going to be negative 2, x plus sine x. It's a negative 3 times derivative of what's inside, parentheses, 1 plus cosine x. Oh, gosh, that was so much easier. And then rewrite it with positive exponents. It's going to be negative 2, 1 plus cosine x on top, and x plus sine x cubed on the bottom. Same answer. I think that was what. I think that's worth it. It's up to you, though. I'll give you full credit either way. Show your work. This one, I find it useful to rewrite these powers on trig when I'm doing derivatives, just because I feel like it's easy to think that the sine is the outer function. It's not. So f prime of x equals 2 sine of x over x minus 1 to the first power, and then derivative of what's inside is going to be cosine x over x minus 1. And then we got to take derivative of what's inside that, and that's going to be quotient rule. Low d high minus high d low all over low squared. That was kind of crazy. Now let's clean it up. I mean, this is going to be x minus 1 minus x, so the x's cancel, and there's a negative, so it's going to be negative 2 sine x over x minus 1, negative 2 over x minus 1 squared, sine x over x minus 1, cosine x over x minus 1, something like that. Seems good. Okay, 22. Like I said, I just think it's helpful to rewrite it like that. This is kind of a lazy way that we always write it, which is, well, that's nice. Let's just not write set of parentheses, but that's what it means. And I think this is easier to work with. So, f prime of x equals 3 sine cosine 4x second power. Derivative what's inside. Derivative of sine is going to be cosine 4x. Oh my gosh, that's crazy. Derivative of what's inside that is going to be negative sine 4x. Derivative of what's inside that is going to be 4. Wow. That's a nice chain. Okay, now what can we simplify here? There's trig inside trig, so be careful with that. This is not cosine squared. Definitely not. Okay, and we could say negative 12. We could put the regular sign first since it's simpler or something. I don't know. And then you have a sine squared cosine 4x times cosine of 4x. And that's all you can do. You can't, like I said, this is not cosine squared. And you can't combine these together and say sine cubed because this is sine of 4x. This is sine of cosine of 4x. It's different. It's inside that. Okay, 23, find the second derivative. So the first derivative is going to be a product rule. X times derivative of cosine is negative sine plus cosine. Derivative of x is 1 minus 2 sine. Remember, this is sine x squared. So you do the derivative first of the power rule, and then derivative of what's inside is cosine. So we could maybe try and clean this up. Negative x sine x plus cosine x minus 2 sine x cosine x. That's the best we can do. Now we got to do the second derivative. So we got to do product rule here. Negative x times derivative of sine is cosine plus sine times derivative of negative x is negative 1. Derivative of cosine is negative sine. We have another product here. Depends on how you want to do with derivative or the negative. You could do it in parentheses 2 sine x times derivative of sine is negative. Derivative of cosine is negative sine plus cosine x times derivative of 2 sine x is 2 cosine x. And then we got to distribute this. Okay, so this is kind of a mess. Negative x cosine x minus sine x minus sine x minus 2 sine x. Oh, hold on. 2 plus 2 sine squared, right? Minus 2 cosine squared. I think the best we can do is just combine these two guys together, like terms. But otherwise, I don't know. I think this is about as simple as it can be. You could use some Pythagorean trigonometries to get the cosine squares into sine squares and sine squares into cosine squares, but they're not going to like go away. So, okay. Next one, got a little product rule here. Derivative of secant is secant tan then you got to take a derivative of what was inside of that just once. Now I'm going to think of this as 2x and negative 1, at least for the derivative part. So it's going to be negative 2x and negative 2 plus, this is product rule, we only do the first part, secant of 2 over x times root of x cubed is 3x squared. Okay, so now we're going to try and clean this up. This is going to be negative 2x secant 10 plus 3x squared secant. Okay, that's it. All right, now for some implicit differentiation. So, and we're just trying to find dy dx. So it's going to be 2x minus 2y dy dx equals product rule 6x times root of y is dy dx plus y times root of 6x is 6. So here's your dy dx. You've done the calculus. Now for the algebra, getting dy dx by itself. So we could do 2x minus 6y equals 6x dy dx plus 2y dy dx. You want to get the dy dx's on the same side, whatever side you want. So then we're going to factor out the dy dx so we can get them together. And then divide both sides by this. Now let's, we can definitely take a 2 out of everything on the top and bottom. So the answer is x minus 3y over 3x plus y. Or if you would move stuff to other sides, you might have got 3y minus x over y plus 3x. Same thing. All right, so I can multiply and top and bottom by negative 1. Well, no, it's not the same thing. These would be negative then if you did that. So, okay. 26. So it's going to be x cubed times root of y squared is 2y the first dy dx plus y squared times root of x cubed is 3x squared. So that's just the first product rule. And then there's another product rule here. 5x squared derivative of y is dy dx plus y times derivative of 5x squared is 10x plus derivative of x is 1 equals derivative of 1 is 0. Be very careful here. I've put some parentheses here just for looks, and some of them actually going to make a difference because we have to distribute that subtraction. So we're trying to get the dy dx's together. So it's going to be 2x cubed y dy dx minus 5x squared dy dx. And then we're going to move the other stuff to the other side. So we're going to get a negative 10xy. So we're going to add 10xy. We're going to subtract a 1. We're going to subtract a 3x squared y squared. And then we're going to factor out the dy dx. And then we're going to divide both sides by that. So there's your answer. I don't think there's anything we can reduce out of it. So implicit differentiation usually results in y's, almost always results in y's in your derivative answers, which is fine. So there you go. We have another one here. Now, I'm a little sketchy about, I mean, we can maybe cross multiply, I'm not sure. That might cause some problems. But, let's try it 2 ways. We'll just try it the way it's written. Derivative of x is 1 equals low d high minus high d low all over low squared. Now at this point, I'd multiply this guy over to the other side. And here I'd FOIL this all out. You're going to get x minus x dy dx plus y minus y dy dx minus x minus x dy dx plus y dy dx. And we want to get all the dy dx's together on the same side. Seems like it might be good to go and FOIL this also. X squared plus 2xy plus y squared minus x. Actually, the x and the minus x cancel. And then there's 2y, so it's going to be positive 2y. So we're going to subtract 2y. And then we get dy dx equal, we're going to factor out negative x minus y minus x plus y. So the y's cancel. So we get dy dx equals x squared plus 2xy plus y squared minus 2y over negative 2x. And that's a possible answer. If you cross multiplied, I don't know, I guess we could try it, but I'm a little sketchy on this. Because it really changed, rational functions, when you just get rid of their denominators, weird stuff happens. But we could try that. Let's see, it's going to be 2x plus x times derivative of y is dy dx plus y times derivative of x is 1 equals 1 minus dy dx. I mean, it's a lot cleaner for sure. And then you get your dy dx's on the same side. Factor out the x. That's going to be a plus 1 equals 1 minus 2x minus y. And then dy dx equals 1 minus 2x minus y over x plus 1. Now, are these the same? Maybe. I mean, the one test would be try and get both of them into purely x or purely y, which I don't really think would happen on this problem. I don't think you're going to be able to solve for x. I guess you could. Anyways, okay. 28, find the equation of the tangent line. Okay, well, we got a point. All we need is a derivative, and then we're done. Okay. So we do the derivative. It's going to be x to the fourth times derivative of y is dy dx plus y times derivative of x to the fourth is going to be 4x cubed plus y cubed times derivative of x squared is 2x plus x squared times derivative of y cubed is 3y squared dy dx equals 10. So that's the derivative. Now, I don't want to get dy dx by itself first because I have numbers. I'm going to plug these numbers in right now. That's the best bet. So we're going to get 1 dy dx plus, this is going to be 2 cubed is 8, 32, so that's going to be 32 plus, shoot, I messed that one up. X is 1, cubed is 1, that's going to be 8. Okay, plug 2 in for y, that's going to be 8 times 2 is 16, plus this is going to be 1, that's going to be 12 dy dx equals 10. I'm trying to do a little bit of the simplification at the same time, but I almost screwed up. It's going to be 13 dy dx equals negative 20, or that's 24, so it's going to be negative 14. And so dy dx equals negative 14 thirteenths. That's your slope. So now we got to find the equation line. It's going to be y minus 2 equals negative 14 over 13 x minus 1. Just leave it. Please leave it. Do you really want to try and get that into slope intercept form? No. I mean, and you could have tried to get dy dx by itself earlier. That's a lot of extra work, I think. So, okay, last couple if y equals sine u and u equals v squared and v equals 4x, then dy dx equals what? What's that mean? Okay, well, if we take the derivative, if we do, we take the derivative, well, let's just plug it in. Y equals sine v squared, right? And we do that. Y equals sine, if you plug 4x into that, that's 16x squared. So then y prime equals cosine of 16x squared, chain rule, 32x. Answer A. Maybe there might be a different, I don't know, slightly different way to do that. But I mean, because we could say, well, dy dx equals dy du, and then du dx, and then, no, du dv, and then dv dx, right? So then the du's would cancel, and the dv's would cancel, and you dy dx. So we could say, well, dy du equals cosine u, right? And du dv equals 2v, and dv dx equals 4, and you could plug those all in there. That'd be cosine u times 2v times 4, but then you got to change everything back into terms of x. So you could say, well, u is v squared, and v is 4x, and so we get 32x cosine of 16x squared. I don't know. So, okay. Number 30, for what values k, we'll have two horizontal tangents. Only we'll have two horizontal tangents. So horizontal tangents are where the derivative equals 0. So I guess we got to try and find the derivative and set it equals 0, right? So y prime equals 3x squared. K is a number plus 2kx plus 1 equal to 0. Okay, so then we'd want to solve for the x coordinates of where these horizontal tangents happen. And I think we have to use quadratic formulas. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that'd be negative 2k plus or minus 4k squared minus 12 over 6. Now, this is the interesting question. We want two horizontal tangents. Well, how's this going to give you two answers? Or does this give you two? This always gives you two answers. Well, sometimes it gives you one. Sometimes it gives you none. It gives you two if the discriminant, the thing inside the square root, is positive. If it's equal to 0, it gives you 1. If it's negative, it gives you none because it gives you imaginary. So I guess we got to go with this and try and solve this now. 4k squared minus 12 must be greater than 0. So 4 times k squared minus 3 must be greater than 0. So we could factor this, k minus root 3, k plus root 3, and we're going to do a line check. Yeah, line check. It's been a while since we've solved a polynomial inequality. So k equals root 3, k equals negative root 3. So line check, negative root 3, positive root 3, test a value. I think 0 might be a good one for k. And it comes out negative, so it's false, true, true. So the values of k, it's actually interval notation. It's going to be, you say k is greater than root 3 and k, or k is less than negative root 3. So that's one way you could write the answers. Or you could say negative infinity to negative root 3 union positive root 3 to positive infinity. And that's another way of writing it. You get interval. You're getting intervals to answers. So do you guys see that answer on here? K is greater than 3, K is less than 9. So the answer, since it's multiple choice, is C. But you get, or no, not C. D. These guys didn't have the square roots in them. So there you go. That's it. Test should be less problems, a little bit less than this. And then you got to be able to finish it in pretty much like 60 minutes, 65 minutes, 65 minutes if you use the extra time out for you. which would be an extra 15 more minutes than I've spent on this so far. So be ready. This is a good problem for people who like the details. It's not a lot of deep thought here. There's a lot. You just got to be super careful, show your work, be organized, know the rules. And yeah.